Instead of creating stub functions, we can make use of default values. This is another strategy we can use to keep from breaking legacy code. JavaScript doesn't enforce parameter count or type. In essence, we can call a function with fewer parameters than it expects, or even more parameters than it expects. We just saw that with the previous example. The draw function was called with color parameters even though it didn't expect any. If we fail to provide a parameter that a function is looking for, that parameter will be undefined. If we pass in additional parameters, they will not be assigned to a name variable, but can still be accessed with the arguments array. This will work, but it becomes difficult to maintain later on. We won't go into that method in this video. Named parameters don't enforce content, but at least there's some hint about how the parameters are intended to be used. This highlights the importance of using meaningful parameter names in our function definitions. Let's go ahead and add the stroke and fill parameters to our original draw function and abandon the stub pattern we used in our last example. We've decided that strategy won't work for us. We accept 6 parameters and there's no indication which of them will have default values. That's because JavaScript doesn't provide a mechanism to automatically provide default values for parameters that are not supplied. Any named parameter that is not passed by the calling code will be undefined. We can check for that condition and supply the default values that were expected in legacy code. This lets us expand our name parameters without having to manage an additional stub function or change legacy code. The result is exactly the same as using a stub. Just as we get ready to test, our phone rings, and the boss says that the executive dinner just finished and the website needs 2 more rectangles in the remaining corners. They need to be ready to go in the morning, and we should be getting a text message with the dimensions and colors. Thankfully, the line goes dead before we make a career-adjusting remark. With our latest version, we can add the 2 rectangles quite easily. We'll test out the default fill color on the rectangle in the bottom left of the page. Notice how we get a silver fill on the rectangle that didn't have a fill color. That's our default value at work. Things are starting to look up. At this point, we might be thinking it would have been easier to just go change all legacy code to make use of the latest version of our function. If we wanted to go make changes to all functions in the legacy code, assuming we even had access to all of it, we could just do a global search for references to our draw function. This isn't always possible due to compartmentalized code, code obfuscation, or even company policies. Many development shops have strict rules about doing regression testing for any code that changes. Making global changes may incur significant testing costs. If we did want to make global changes, there is a benefit of using the stub strategy. It's easy to find all references to the legacy function definition. Since each stub has a unique name, it is easier to locate all references within the project when it comes time to retire support for that version of the code. With the strategy of using default values, it isn't so easy to locate all references to the function that have only 4 parameters instead of 6, or all references that have 2 parameters instead of none. There are ways to do this with regular expressions, but it's not for the faint of heart. Let's fix all our legacy code once and for all before we break it completely with one final strategy. We're going to fix it with default values for all the parameters.